Okay, so lesson 7.4. In this lesson, we are going to move from specifically parallelograms to more specific types of parallelograms, and there are three. One of them is a rhombus, and a rhombus is a parallelogram where all four sides are congruent. A rectangle is a parallelogram where all four angles are right angles. And a square is essentially a combination of a rhombus and a rectangle. It has four congruent sides and four right angles. Okay, so those are the big properties of a square. Rectangle, parallelogram with four right angles. Rhombus, four congruent sides. So they have all the other properties of a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. So there are a lot of things to remember, but essentially we got to remember that they're all still parallelograms. Okay, so in our first example, we're going to be using properties of these special quadrilaterals. And the first one is talking about a rhombus, QRST. So in the middle of these two statements, I am going to draw a rhombus best I can, and it's QRST. And all I've told you so far is a rhombus, all four sides are congruent. Now, what I am asking here is this always, sometimes, or never true? Is Q congruent to S? Q and S are opposite angles, and our rhombus is also a parallelogram. So for part A, this is always true. Opposite angles are congruent. Sorry about that. That was my phone going off. So opposite angles are congruent. So since this rhombus is also a parallelogram, the opposite angles are congruent. Okay? So Q and S are always congruent in that rhombus. Now, in part B, is Q, I'm going to use blue for this, is Q congruent to R? And what I will say to that is that in a rhombus, this is only sometimes true, okay? And the reason this is only sometimes true is that in parallelograms, consecutive angles always add to equal 180 degrees. So the only way this could be true is if both of these angles were 90 degrees. If both of these angles were 90 degrees, QRST has to be a square. So it's just thinking about the special properties of each of these. So opposite angles are still always congruent. Consecutive angles still always add to equal 180. We're just thinking about more specific shapes today and how to describe their properties. Okay. In example 2, classifying this special quadrilateral, we've got to be as specific as possible. Now, all four sides are congruent. So right off the bat, I'm thinking for sure it is a rhombus. Okay? And then I would think, if it's a rhombus, could it also be a square? Well, this shape can't be a square because all four angles would have to be 90 degrees. So it's a rhombus because it has four congruent sides. And not all angles are 90 degrees. So again, thinking about properties, the properties are fairly basic, but again, always come back and reference this at the top to help us remember some of these properties, okay? So, some guided practice. Good chance for you guys to look at these questions, think about them, and then answer them to the best of your ability. And then I'll go through them once you are ready. But this part where I ask you to explain your reasoning is really essential to this. Okay, So take a minute, pause the video, and then once you're ready to check your answers, resume the video and I'll explain the answers. Okay, so if you notice for all of these, I drew a diagram. Okay, I drew the shape. So I drew square JKLM, and I marked all 4 angles as 90 and all 4 sides as being congruent. So is it always, sometimes, or never true that JK and KL are perpendicular? Well, JK and KL, for them to be perpendicular, they would have to meet at a right angle. Well, in every square, K must be 90, so this is always true for every square. Okay, for every square, those sides have to meet at a 90-degree angle. That is the definition of perpendicular. For a rectangle, is it always, sometimes, or never true that FG and GH are congruent? Well, it's not true for every rectangle. It would only be true if that rectangle were also a square. So again, the diagram helps me visualize what is going on. And then for 3, quadrilateral has 4 congruent sides. So it's for sure a rhombus, but it also has 4 congruent angles, which means if it's a quadrilateral, 4 congruent angles, that means all 4 angles are 90. That would mean this is a square. 4 90-degree angles and 4 congruent sides. So that's why that would be a square, right? That's the most specific name I could give it. So moving ahead, some more specific properties of diagonals, at least, for a rhombus. So in a rhombus, diagonals are perpendicular, meaning they meet at a 90-degree angle. And the other part of this, the diagonals bisect, okay, the angles. So in this rhombus to the right, A is being bisected, cut in half. B, D, and C are all being bisected, okay? So diagonals are perpendicular, and they bisect the angles, or the vertices. They bisect the angles at those vertices. So in example 3, it says find the measures of the numbered angles. So I'm going to get to work just saying measure of angle 1. Since diagonals are perpendicular, angle 1 is 90 degrees. Okay, angle 1 is 90 degrees. Measure of angle 2, measure of angle 3. I'm going to do those at the same time. If we look at this rhombus, we said diagonals bisect each other. So these 2 angles are both 61. Using our knowledge that opposite angles are congruent, I can also say that angle 2 is 61 degrees and angle 3 is 61 degrees. Because if they bisect and those opposite angles are congruent, well, then I know that the other 2 angles opposite from the 61 are both 61. And then the final angle, measure of angle 4, I'm going to do a little bit of work. I'm going to use my knowledge that angle 1 is 90 and that angle 3 is 61, and I could use my knowledge of triangles and say 180 minus 90 minus 61, or just 90 minus 61. Either way, it's 29 degrees. Angle 4 is 29 degrees. So whenever you're looking at this, it's remembering some properties. Diagonals are perpendicular, they bisect the angles they intersect, and these create basically 4 right triangles that we can find measures of if we're paying attention. So the last property we're going to talk about is rectangles. Okay, diagonals of rectangles. So a parallelogram is a rectangle if its diagonals are congruent. Diagonals are congruent. So example 4 is fairly straightforward. Finding the lengths of the diagonals, it's knowing that QS and RT are diagonals. We're going to find the lengths of those diagonals. So from what I just said, diagonals are congruent, so these expressions are equivalent. So to solve this, this would become 3x minus 31 equals 11, because I subtracted 2x from both sides. 3x equals 42, because I added 31 to both sides. and then x is 14. Okay, so x is 14. And I said to find the lengths. I didn't say to just find x, find the lengths. So I would substitute this into one of my diagonals. Since they're equivalent, it doesn't matter which one I substitute into. So I'm just going to substitute into RT. 2 times 14 plus 11. 28 plus 11 is 39. So over to the left here, I'm going to say QS and RT are 39 units long. I didn't give you units like inches or feet or whatever, but it's knowing set the diagonals equal to each other, solve, substitute back in to find the measures of each diagonal. So, sorry, I will leave that up there for a second. And then I'm going to give you a chance to start the guided practice. So take a minute, try to work through it, and then check your solutions with me when you're ready. Okay, so for this one, just setting them equal to each other. I solved, I got 23 was x. I substituted into one of the expressions, found the measure, and then I just could say both of these are the same measure. They're both 77 units long. So diagonals of a rectangle equal. Diagonals of a rhombus have to do with angles. They are perpendicular and they bisect the angles they intersect with. So you're ready to move on to the practice and then eventually the checkpoint when you are ready.